In this video, I'll demonstrate how resources can refer each other when they are defined inside different stacks. We will continue with the same setup we had for our previous demonstration. We have the to-do service, which will be deployed in Lambda and uses DynamoDB to persist the data. The only difference here is that we are going to use different stacks. To-do service will be defined in one stack, whereas the to-do database will be defined in another stack. In this case, to-do service needs to refer the to-do database through its parent stack reference. With this, let's go to the CDK code and build this. So we are at our CDK code. I've created a new file to implement this. In this, I'm creating our first stack, the one which is going to provision the to-do database for us. As usual, it's extending the cdk.stack. Inside this, I'm defining our DynamoDB table. This is similar to our previous implementations. Additionally, I'm creating a class attribute here. I've named it as todo_db. This is of type dynamodb.table_v2. The newly created table will be assigned to this class attribute. This is our second stack, which is going to provision the Lambda function. Again, it's extending the cdk.stack. Here is the definition for our Lambda function, very similar to our previous demo. Additionally, if you see the props parameter of our constructor, this is not stack props type. Instead, this is of custom type, which I have defined here. This is extending the cdk.stackProps interface. Here I'm defining the additional attribute which our Lambda function needs, which is the reference of to-do database. This is again of type dynamodb.table_v2. This new interface will help us in passing the DynamoDB reference across the stacks. Coming back to the stack and the Lambda function, as I said, this is very similar to our previous demo. It carries the same runtime, handler, and the same code reference. When we are calling the add environment method on this function to set our environment variable, this time we are retrieving the value from the props object, which is based on our custom interface. Within this, I'm getting the reference of our DynamoDB table, which refers this, and then the table name, which is an attribute of the DynamoDB construct. Also, to grant the API permission, I'm using a similar reference, props.tododb. We are calling the grant read-write data method available with this DynamoDB construct, where we are passing the source AWS resource, which in our case is the Lambda function. We are good with the code here. Let's go to our entry point and update the calling code. Before updating this code, let me delete the existing stack in the AWS environment. This is finished. Let's confirm this on the CloudFormation console. And yes, we are good here. Let's uncomment the previous call. Instead, I'll put the new code here. This refers to our newly created file. I'm importing our two stacks here, the DB stack and the Lambda stack. First, I'm instantiating the DB stack with the variable reference. When I'm creating the service stack, I'm setting the to-do props parameter with the reference of our newly created DynamoDB table. As we already discussed, this props parameter is defined in our custom props interface for this stack. That's it for the code. Let's go ahead and deploy this. As we have multiple stacks now, so I'm going to use all option here. The process is started. First stack is completed. It's asking for the second stack now. If we go to the CloudFormation console, here is our DB stack, which is in create complete status. If we go inside resources, it has created the DynamoDB table. Our service stack is also completed now. If we look into the resources, it has created the to-do service, which has the service role and the Lambda function. Just wanted to highlight here that this role should have the required policies for us to interact with the DynamoDB table. We already called the grant method. Let's confirm this. I am in the IAM console. We are looking at this Lambda role. It has two policies attached. The first one provides the basic access to the logs we already seen earlier. The second one, as you can see, has the API calls for the DynamoDB. This is just to illustrate what grant permission is doing implicitly for us. It's defining the right policies to the Lambda execution role so that we can access the DynamoDB table. Let's go back and browse to our Lambda function. This is the same code reference we used earlier. Going to the configuration, it has the environment variable with the newly created DynamoDB table. If we go to the DynamoDB console, here is our new table. This table is here with our previous CDK deploy run, though we ran CDK destroy command, but it does not delete the DynamoDB tables by default. In the new table, if you explore the items, there are no rows currently present here. Let's do a sanity check to our Lambda function. This is the put event with our payload we used earlier. Let's click on test, and this returns the successful response. Let's validate our get event as well. I'll remove the body, it's not needed here. I'll just update the HTTP method type as get. And this returns the successful response as well. The body contains the single DynamoDB record, as you can see, we just created. With this, we successfully implemented and validated the CDK code so that AWS resource present in one stack can refer to the AWS resource present in another stack.